Okay, finally, dividing decimals. So the first step doesn't always necessarily apply depending on what the problem is. So the first step says multiply the dividend and the divisor by the same power of 10 so that they become whole numbers. And you can do that with this first problem. Um, Let me set it up, and I'm going to first just ignore the signs because I'll worry about the signs at the end. So I'm just going to pretend it's 48 and 3/10 being divided by 7. That first step means that if I wanted to make the 48.3 a whole number, I could multiply it by 10, and that would become 483. But if I multiplied that one by 10, I would have to multiply the 7 by 10 as well, to keep the problem the same. And by all means, I can go ahead and do 483 divided by 70 because that quotient would be the exact same. But for this case, I'm just going to go ahead and keep it as a decimal in the dividend. So let me get rid of that. But I just want you to know you could do that and solve it that way. But if I just kept it like this, I will put the decimal straight up where it is in the dividend, okay, into the quotient, just straight up from where it is, and divide like normal. So strategies are standard algorithm. You could actually do partial quotients. Any other strategy, like repeatedly subtracting groups, is fine. You could even do the area model in reverse if you want. I mean, there's so many different ways to think through division. I don't want you to feel like you have to do it this exact way. Okay, I'm just showing you one way. So 7 goes into 48 6 times because 6 times 7, or 6 groups of 7, is 42. And the difference there would be 6. Okay, I was 6 off from being able to fit it in another full group. And then I will bring the 3/10 down. And right now it's technically 6 and 3/10. I'm trying to think again, like how many times does 7 go into 6 and 3/10? Well, not a full group, but if I was treating the 63 as a whole number, 7 can go into 63 9 times, or 9/10 of a group fit into 6 and 3/10. And then I'm done. I have nothing left over because that works out. And so my final answer is 6 and 9/10 groups fit into 6 and 9/10 groups of -7 fit into -448 and 3/10. The signs, a negative divided by a negative is a positive, so I'm just gonna keep it positive. And the decimal's already in the quotient where it belongs. And my answer is reasonable. Okay, always check that. Like, using estimation, does that make sense? It does. Second one, 4 and 32 hundredths divided by 1 and 2/10. Here's an example of a problem where I actually do want to apply that first step. So I'm going to set it up, 4 and 32 hundredths being divided by 1 and 2/10. I'm going to ignore my dog barking. I want the divisor to be a whole number. So I am going to multiply it by 10 because it would make it the number 12. Well, if I multiply that by 10, I have to multiply the dividend by 10 as well. And so we know based on place value that if we move over a place to the right in a number, that it got 10 times greater. And now I put the decimal right straight up from where it is right now in the dividend, which is here. Because again, I have made the divisor a whole number because whole numbers are friendlier. And then I did the exact same multiplication to the dividend. And now I can just divide like normal. So let me get rid of this for just organization purposes. Okay. And now I just go through the process like I normally would. And again, this part is when you just use your own strategy and just make sure your answer makes sense. 12, let's see, 12 going into this number. So 12 can go into 43. And I know this number is technically 432. You can think of it that way. I'm just going to do the standard algorithm. So 12 can go into 43 3 full times, because that would be 36. Or again, it's like fitting it into it 30 times, right? Let's see, and then subtract, and the difference between 43 and 36 would be, the difference would be 7, and then I'll drop that last digit down, to finish this problem. And I'm thinking now, how many times does 12 go into 72? I know 5 groups of 12 is 60, so 6 groups, another group of 12 would be 72, so that would be 6. 12 times 6, again, always go off to the side, just double check. Yep. Okay. So that would be 72, and I would be done. So now I just want to make sure that this makes sense. I'm going to go back to the original problem, and I'm going to think to myself, okay, this division problem is like asking how many groups of 1 and 2/10 fit into 4 and 32 hundredths. And that, like, about 3 or 4 would make sense if I were to just round these to whole numbers. So my answer is definitely reasonable. 3 groups and some more, 3 and 6/10 groups. And it's a positive divided by a positive, which is a positive quotient. And then there we go. The most important part, you guys, is, do you have a division strategy that works for you? And if not, I will see you in the instructional support hours, because I want to make sure that you can think through division using a strategy that makes sense to you, because there's more than just one way. All right. And there we go. So now you will practice dividing rational numbers, and then you will apply what you know to the application assignment. All right. Good luck. And again, instructional support hours, take advantage.